of Geology, and this is about, well, it's two parts. This is about one part about how geology has shaped Alberta's economy with oil and gas, and the second part is about earthquakes, which is really cool. Okay, now there is a fossil that puzzled scientists, paleontologists for many years. It was this weird looking fossil. If you ever go to the Royal Tyrrell Museum in Drumheller, you will see this thing in kind of those, like, you walk into the rooms and there's all of the different creatures on the seafloor. This is there, this thing. And they didn't know what it was. It was so bizarre that artists kept they would keep finding this fossil, and they tried to figure out what it was. They actually called it hallucinogia, because when you looked at it, it basically was like you were on an acid trip trying to figure out what it was. So there you go. People were like, what? What's going on? Is it like it had spines and a weird looking head and a weird tail? And it's changed a lot. So what they think now is that it had fleshy little legs and hard spines. And that's what it's so bizarre looking, isn't it? But if you go to if you go to the museum, there's these little creatures. They lived all over the place in Alberta millions and millions of years ago on the bottom of the sea floor. And I say sea floor, you're like, what? It's true. Okay. So one of the things that's really interesting about Alberta is that we have one of the largest deposits of fossils in the entire world. There's a reason why we have the Royal Tyrrell Museum, because there's so many fossils found in southern Alberta. And why? Why are so many fossils found in Alberta? Well, millions of years ago, because of plate tectonics, there was this massive inland sea, huge, and it was from basically the Red Deer region all the way south to the United States and over into Saskatchewan, this huge inland sea. And this started during the Paleozoic era. So that's about when the sea occurred. Now, what lives in the sea? Well, creepy crawly sea things. So we have all of these sea fossils. What feeds a sea? Rivers, lakes. So it was an area of growth and an area where dinosaurs could get water. And that's how you get a fossil, is when something dies around water and it gets quickly covered up with sediment, either through a flood, if they're away from the ocean, or they die and fall to the floor of the ocean and get covered up with sediment. So remember, this is how a fossil is discovered. So if a dinosaur died in a desert, very unlikely that it would get fossilized. Most dinosaurs only are found by luck based on where they die, and they would have had to die normally. A lot of dinosaurs died from floods. A flood would come and sweep them away, and they'd get covered up with the grime in a river that was being brought on by a flood. Okay. So during the Cambrian time period, there's this huge explosion of life, and that's where most of Canada's fossils come from. Most of those fossils are trilobites. It was the world of the trilobite at this time, but also the trilobites fed on plankton. Ancient plankton and sea sponges were around, and things that lived on the sea floor. So all of these animals, all of these dinosaurs, all of these creatures at this time were living in this sea that was in Alberta. So what was our oil? Like, we have all of this oil and natural gas in Alberta and the western part of Saskatchewan. Well, it's from this sea. That's where all of our oil and gas come from, this ancient ocean. It's really hard to wrap your head around. But when you fill up your car, you guys are getting gas in your car, it's not made of dinosaur, though maybe that's why you have to pay for premium. It's got extra T-Rex in it. It's not made from trilobite. Zeus didn't make it. It's from this ancient inland sea. And oil and gas is non-renewable. Like, you can't clone dinosaurs, smack them upside the head, and bury them again to get oil. It doesn't work that way. It takes millions of years for the oil to form. Okay. All right, so let's just recap. You might want to be filling in your notes here. I'll go kind of slow. So our oil came from these reefs, and everything that lived in the reef that died and was covered up by any kind of sediment over millions of years was compressed into oil and gas. Oil was the planktons and the sea sponges and like the aquatic stuff and maybe trees became the coal. So oil is from microscopic organisms that gooified into the black sludge that we know of oil. And from oil, that gets sent through different processes, and it gets separated into different things that we use, like gas that goes in our car. So how big was this inland ocean? Half the size of Alberta and Saskatchewan. So it was huge. It was enormous, stretched up to the Northwest Territories. Like there was this big gap that isn't here today. I'll have a link that will show you guys this inland ocean in the daily plan. Okay, so this oil gets these oil pockets that get covered up with sediment, kind of like slapping your hand on top of each other. That's called a petrotrap. And hundreds and hundreds of years ago, it would actually bubble to the surface. It still happens today. And ancient cultures would find it, and it would usually be a poisonous, toxic, bad area that they would stay away from because poisonous gases would escape. Oil is very toxic, so people that would touch it or try to eat it or use it might get very, very sick. Some cultures knew that it was flammable. Most cultures did not understand what oil was, and they stayed away from it because it was poisonous. It was dangerous to them. Okay. So, how do we find oil and gas? Well, back in the day, or even today, the first step is you have to drill a sample hole. So you have to drill a hole, and we'll get into maybe why new tech doesn't have to do that, but you have to drill a sample hole. So if this is the ground, a fairly deep hole is drilled, and you take samples from the hole. So this is like various types of rock. So when the core gets brought back up, you'll have this thin kind of tube of rock, and geologists can analyze what's in that rock to determine there's a more likelihood of oil being there. Because remember, oil doesn't get through rock that's not porous. There's types of rock like shale where oil can seep through it. And there's other types of layers like clay where oil cannot get through that at all. So if the whole thing is clay, the geologist is like, probably there's 0% chance of there being oil here. So you have to drill another test hole. Now, back in the day, they would basically drop a bomb and take readings. So in this test hole or other holes, they would put an explosion down there, boom, blow it up, and the shock waves would travel everywhere. And there'd be some dude or lady on the top, a geologist, that would measure the waves as they traveled through the ground. And the speed of that wave travels differently through something like a natural gas deposit, which is gas. So it would travel very, very slowly because the molecules of gas are spread apart. But if it hit something like oil, it would travel a little bit faster. If it traveled really, really fast, it was mostly rock. So that's what they used to do. Now they use much stronger like sound waves. So instead of dropping a bomb, they bombard the ground with sound and see what it bounces off of. There are probably places in the world that still use seismic explosions to figure out what's going on. Okay, so recap. A drill sample allows geologists to determine what rock is found below. Okay, that's awesome. And after this Cambrian time period where all the life started to go crazy, go nuts, the plankton, plankton, and sea plants within this ocean became what we use for oil and gas. It really is mind-blowing that our houses are heated from the natural gas from this time period. Like when you are in the winter and your house has that natural gas burner going, we are burning basically the decayed remains of this stuff. It's kind of crazy. Okay, last picture for recap. So this is a cross-section of the Earth. And when oil companies go to drill, maybe they might drill incorrectly and they might hit a dry hole. And it's really mind-blowing, but they have to be careful because not only is oil trapped underneath the ground, not only is gas trapped under the ground, but ancient salt water from this ancient ocean is under the ground. So oil companies that drill too deep or in the wrong spot can have salt water shoot up. Now, what's the problem with that? Well, you've just wasted a lot of money because you can't sell salt water. But if you don't control that salt water, there have been catastrophes where it's spread to the ground and basically destroyed farmland for farmers that are around that area. It's a big problem in Alberta right now. There's these wells called orphan wells where oil companies drilled them, didn't make a lot of money, and the companies have gone bankrupt, and they've just left the drill and the well there. And because they're bankrupt, farmers have no recourse to fix the problem. Where oil and gas might be trapped is underneath special types of rock that don't allow it to get to the surface. So when the seismic energy goes through, it's going to go really fast through the rock. It'll go really slow through the gas and then kind of medium speed through the oil. And then they can decide to drill down to get gas, which is usually much shallower, or they could drill deeper for oil. And I don't want to make this lesson too long, but before I became a teacher, I worked in the oil patch as a rig hand. I was a roughneck and then a derrick hand. So I worked on the service rigs that put the stuff in after the drilling rigs punched the big holes. So you know those pump jacks that go up and down? We were the crew that got those set up to be put in. It was I liked parts of the job and I didn't like parts of the job. And it's too bad we're all on quarantine because that's a big part of my story for this. Is I know some of you probably have family members that work in oil and gas. So I've included a blowout video because when you're drilling, you have an enormous pressure from these layers. That's trapped ancient gas. It's like a balloon. And what you're doing is popping the balloon and it's going, so you have to control that pressure. It gets really dangerous. Okay, so that's the lesson for today. There's a little Google form you can try that goes with this. Please get the other assignment to Floop done if you haven't. Okay, thanks.